m'appelle Simon Morin et je suis architecte chez Leboncoin. Je suis arrivé en 2012 au sein de ce qui ne s'appelait pas encore l'équipe data. 9 ans plus tard, l'équipe est passée de 5 à 50 personnes. Elle accompagne au jour le jour une quarantaine de feature teams et opère la plateforme de data processing sur laquelle reposent l'analytics et les pipelines de machine learning du Leboncoin. Cette petite équipe a donc bien grandi, à tel point qu'elle est devenue un département à part entière, une tribe dans le jargon local. Et pourtant, elle peine de plus en plus à encaisser l'augmentation des demandes, la faute à la croissance des équipes PNT et aux besoins de produits data-driven. C'est dans ce contexte que nous sommes intéressés au concept de data mesh proposé par Zach Degani de Taskworks. Elle proposait à la fois une analyse systémique du problème, qui semblait tout à fait pertinente, et des leviers activables pour en sortir. On s'est donc mis à chercher des pure players qui auraient basculé vers ce modèle de data mesh, et on a fini par tomber sur Harry Wider, consultant chez Taskworks, qui a accompagné Max Schulze, data engineer manager chez Zalando, dans cette transformation. On a la chance de les avoir aujourd'hui avec nous. Leur retour d'expérience nous a beaucoup inspiré, c'est donc un réel plaisir de les accueillir ici et maintenant.
Hello and welcome everyone to Data Mesh in Practice. I'm Max Schulze and I'm joined here today by Arif Vida to talk to you about how Europe's leading online platform for fashion goes beyond the data lake. Before we are diving right into the topic, let me first give a short introduction of who's actually speaking to you today. Who are we? So as I already mentioned, I'm Max Schulze. I am a lead data engineer at Zalando, Europe's biggest online platform for fashion. And I've been working with the company for around 5 years now in the data space. What I've mostly been working on was distributed systems in terms of data processing, in terms of data storage, and building a lot of data pipelines and services and tooling around data. On the private side, I'm a huge gamer. So I've been playing a lot of League of Legends, a lot of Animal Crossing, but most importantly, I've probably spent like the most significant portion of the last decade traveling around the world for Magic the Gathering tournaments. So if you are interested in having a chat about gaming after the session, feel free to chat me up on that. Arif, do you want to give a short introduction for yourself?
Yes, so hey everyone, I'll make this quick. My name is Arif. I'm a technology consultant with ThoughtWorks as well as a software engineering professor at HTW Berlin. And before moving back to academia, I was leading the data and AI business of ThoughtWorks Germany. And as part of this, I was working quite some time in various data teams of our clients, often as a data engineer. And this is also what brought me to Zalando, among other clients, and ultimately how I met Max. And yeah, on a quick personal note, I am a serious geek when it comes to coffee. And that's really it. So let's get going.
Thank you, Arif. So what can you expect from us today? Well, the first thing that I would like to present to you is Zalando's data platform, basically how it used to be before we started our big data mesh journey. And once you got an overview of what was the starting point of our journey, we will start diving into what is this data mesh actually about and give you a quick background about this new theorem that is making a big fuss all over the world right now. And once we're done with that, I want to follow up with a point about presenting you a bit how we apply data mesh in practice. What are the parts of the theorem that we are now putting into our daily life at Zalando, in our daily business, and how do we really support this big change in terms of an organizational level, but also in terms of a technology level. That being said, let's just dive right into it and start talking about Zalando's data platform. So generally speaking, when I mention Zalando's data platform, I'm speaking about three big areas. I'm usually speaking about ingestion, how the data is actually getting into the analytical platform, how the data is made available. I'm talking about storage, how the data is stored, but not just the data itself, but also additional meta information about the data. And then there's the third big part, which is the serving layer, which is how you can actually access this data, how you can make use of it, and what are the different services and platforms we offer on that side. On the ingestion side, at Zalando, we have three major data sources where data is made available to be consumed for the rest of the company. The first one is we have a company-wide event bus, which is an API wrapper around Kafka, where a lot of teams are using their data and communicating for service-to-service communication. But of course, this also provides a lot of very useful data when it later comes to analytical processing. And that's why we have a dedicated data pipeline to archive everything that is flowing through the company-wide event bus. Second, we have still a legacy data warehouse. Everybody still has some legacy. And even though there are bigger projects going on to get away from that, there's still a lot of very valuable information and knowledge in this data warehouse, so that it makes a lot of sense to also extract this information and make it available also to a broader audience in a cloud-native setup. Lastly, we are customers of Google Analytics when it comes to tracking information about the users and their behavior on what they are doing on the website of Zalando. And we are also extracting this information and making it available, which especially increases in its value when combining it with other data sets. For instance, checking the behavioral data on the website on how the users are navigating around and combining this with some sales information can give you very strong indications about what are the things that work well on the platform and what are the things that can potentially need improvement. On the storage side, we were at that time looking for a simple storage solution, and we went with exactly that, which is AWS S3. Zalando is an almost exclusively AWS-based company when it comes to its cloud operations. And that's why it was pretty clear for us when we were looking for a scalable yet cheap storage solution for terabytes and by now even petabytes of data that we went for S3 in this particular case. As I already mentioned, storage is not just about the storage of the data itself, but this is also about storing additional metadata of this data. And here we are really speaking about additional information like inventories about what the data that you actually have, about usage data that is actually allows you to analyze what are the particular data sets that are heavily used within your company. And on the serving side, we have somewhat of a split approach when it comes to analytical processing, which is much more on the side of, let's say, attack analysis, on report generation, and on just like reading data and making use of it as it is. For that, we are using Presto as a distributed SQL engine, which gives good interfaces to a lot of our analysts, which can then work directly with this system. When it comes to data transformation or data processing, that's where we have built something that we internally call a processing platform, which basically is Spark as a service offered to the rest of the company. We are a big customer of Databricks here, and we are using their platform internally to tailor to the needs of Zalando and make sure that a lot of teams can access Spark resources as they need without having every team take care of the responsibilities for the infrastructure by themselves. Lastly, we have a data catalog where we are using Colibra internally when it comes to documentation of your assets, but also for managing a lot of processes, like for instance, access control for the data. This is our central point, our central entrance point for working with data when it comes to the side of discovery and when it comes to the side of starting to work with data. The interesting point about this setup is that a lot of the things that you see here are mentioned centrally. And central management of all your data infrastructure and of all your data components has quite some downsides that we started seeing more and more over time. I want to mention a few of these centralization challenges. And the first one that we actually observed was that data sets provided by the central data infrastructure team led to a lack of ownership. Whenever somebody was using data and trying to make sense of the data that was stored in the central data lake and that had maybe some issues, was maybe lacking some documentation, it was really hard to actually get to the core of these things. It was really hard to find out who was actually owning this data, who was responsible for this data. Because a lot of the times, these data sets were produced by some team with the purpose of service-to-service communication, but then also archived for analytical purposes as a byproduct. Sometimes even without the knowledge of the producing team that these cases were really used also for analytical purposes. And because of that, there was like a total lack of responsibility and of ownership to actually take care of issues that analytical users of these data sets were potentially facing. Secondly, data pipelines operated by a central data infrastructure team led to a lack of data quality. I'm myself coming from the perspective of a data infrastructure team. And when we are looking at data pipelines from an infrastructure perspective, we are processing thousands of data sets. We are processing petabytes of data. And when we look at quality of data, we rarely dig in deeper than to a data set level. What I usually care about is the latency of my data pipeline. It's the general throughput, how much I can process over time, and that the pipeline as a whole is running. But I never have the chance to dig into a single data set and identify that some of the records are potentially corrupted or are missing some values. And again, because there was no clear ownership, it was really hard to understand how to address certain quality issues of the data. Last but not least, the moment the organization started scaling and the usage of data started heavily scaling, the central team immediately became the bottleneck. Whenever any of the data consumers had an issue, because there was no direct way of addressing the potential producer of this data, all they always had was reaching out to the central team because they were the ones providing the data. So all requests that came down to any kind of issue with the data were always funneled through the one central team that was taking care of that. And that, of course, is a problem in itself because the central team, on the one hand side, tries to help, but they don't have the domain knowledge to even look into some of these issues. They are trying to solve issues, which on the one hand side, they are not even responsible for, but on the other side, they don't even have the knowledge to help in a lot of these cases. And a lot of the time, it really boils down to trying to understand where this data actually comes from and trying to find a team that has the required domain knowledge to actually take care of that. These were the three big issues that we were seeing over the time, growing more and more, that eventually led us towards the push and the change of the paradigm that we were actually applying when it came to handling data. Arif, can you maybe tell us if we were the only ones who were facing these challenges, or if there has been other contexts where you have seen similar things already happening?
Yes, certainly. So having been a consultant and having worked in several data teams with different clients, as I mentioned before, I can really confirm that what Max just described is a recurring pattern that I see again and again. And when you look at this situation a little bit from afar, you can usually identify three different parties, so to say. So on the left side, you have the party of the data producers. So those are the people who run the production services and generate data from those production services. And they are usually kind of okay with the situation, or let's say they do not feel the pain of lack of data quality and data ownership that much, as long as they are not consuming the data themselves. And then on the right side, we have the party of the data consumers. And those are data scientists, but also decision makers. Those can also be production service teams that consume their own data. And they really feel the pain of a lack of data quality because they are the ones who try to make sense of all of this and really suffer from poorly documented data and those kind of things. And then in the middle, we have the party of the people building what is usually a central data system. So those are often data and machine learning engineers, and they are in an even tougher spot than the data consumers, because they often find themselves in a situation where they basically do firefighting all day, trying to solve issues that have been introduced upstream or by changes upstream, while at the same time not really understanding or knowing the data. And therefore, it's quite hard to solve those issues. And at the same time, they are not even the ones who actually build the applications on top of the data. So they also do not know the specific requirements or kind of why certain data is needed and other data is not needed. So this is really not a great situation, not for this central data team, but also not overall. Now, interestingly, this situation comes up no matter whether you're building a classical data warehouse or a bit of a more modern data lake, as long as you have a central data platform with central ownership. Now, why is that the case? Imagine that on the left, you have an ever-growing number of data producers or data sources. And on the right, you have an ever-growing number of data consumers and data applications. Now, the reason why this is not scaling with a central data platform is that such a central data platform with central ownership usually cuts through domain boundaries. So what do I mean with this? Let's imagine that there is a checkout service, for instance, and that checkout service is maintained by a team of people who are running the service, and this service is generating checkout events, right? And those events, they end up in the central data platform, which is owned by another team. Now, already in this situation, you can see that now the knowledge about checkouts, kind of when checkouts happen and all the things that you need to know about checkouts, this knowledge is scattered across at least two teams. So, and that means that also the ownership and the responsibility is scattered. And this leads to misunderstandings, to friction, and ultimately it leads to this model to not scale. That means kind of it might work as long as you have very few data generating services, but the more that the number of data sources grows and also proliferates, at some point, really this model with a central data platform comes to a creaking halt, so to say. And this is really where the data mesh comes in. So let's talk about what data mesh or the data mesh paradigm really is. So the data mesh is mostly about applying concepts that have already been applied successfully in the general software engineering domain to specific challenges when dealing with data. And that means mostly that it's about 3 core concepts. And that is about applying product thinking first. Then second, it's about domain-driven distributed architecture. And third, it's about infrastructure as a platform. And before I go into those one by one, let me quickly refer to the original article by Zhamak Dehghani, because she is really the one who coined the term data mesh and wrote the original article, which you can still find at martinfowler.com. And in this article, she really explains in far more depth than what I can present you here in those few minutes what the data mesh is. And she also wrote an excellent second article by now, which is very much worth reading as well. All right, so let's start with data as a product. And I like to start with this one because I feel this has the highest potential to solve those ownership issues that Max mentioned earlier. So what does it mean to treat data as a product? Well, it actually means that you treat data as if it was a physical product that you want to sell. So basically it means that you need to think about things like, what is my market? Who are the people who are actually using my data? And how do I actually make sure that those people even know where that I'm offering this data, right? How do I make sure they get to know about this offering? And dealing with those questions thoroughly often means that you want to have a dedicated role of a data product owner. And such a data product owner can really think about a data product roadmap and think about how to develop this really as a product. And ideally, such a data product owner is part of a cross-functional team that has all the capacity and all the knowledge to build everything that is needed to provide this data as a self-sustained offering. So all the data pipelines, etc., to provide this data. Now, coming to the second concept here is domain-driven distributed architecture. And what this is mostly about is to really make sure that such data products focus on one specific domain or a subdomain. And when focusing on one subdomain, that means that the team that builds such a data product, that they really can become domain experts for this specific domain or subdomain. And with this, the different domains and data products really can become building blocks to build on top of each other. And there are kind of different domains and data products. So you can have so-called source-aligned data products that are very close to where the data is generated, so to say, and you can have more aggregated domains and data products that rather create additional value that builds on top of other data products. Now, coming to the situation where you kind of build data products together, you can only get there if those data products fulfill certain requirements. And that means mostly that they need to be discoverable, they need to be addressable, they need to be self-describing, secure, and trustworthy. And most importantly, they need to be interoperable. Otherwise, kind of you cannot get to this network effect that you want to reach. And then finally, let me talk about data infrastructure as a platform. So generally, the idea of providing infrastructure as a platform is nothing new. This is what the big cloud providers are doing for years. And at first, the idea is simply to make sure that you do not have to build infrastructure again and again and have duplicate efforts here. And this is also the same idea that you want to follow with a self-service data infrastructure platform. The important thing when building a data infrastructure platform is, however, that you make sure that it stays domain agnostic. So what do I mean with this? I mean that if you are a data engineer that is working in such a team building a data infrastructure platform, and you realize at some point that you need detailed knowledge or that you need to understand in detail something about a specific data product and their data, then you're already on the wrong track again, and you risk that the data infrastructure platform becomes a monolithic central data platform again that takes data ownership. So you need to make sure that the data infrastructure platform really stays domain agnostic. That means it supports the people that build data products in a generic fashion, but at the same time really helps them to build their data products more quickly and with less effort. So summing things up here a little bit before I hand it back to Max, who can tell you more about specifically this data infrastructure side of things, let me reiterate that the data mesh is not so much about technology as it is a mindset shift. So it is about going away from centralized ownership to decentralized ownership. It's about looking at domain data as the first class concern and not so much at looking at technical things such as pipelines. It's about treating data as a product and not as a byproduct. And it's about going away from siloed data engineering teams to cross-functional domain data teams. And finally, what you want to achieve is to get to an ecosystem of data products. And with this, I hand it back to Max.
Thanks a lot, Arif, for this great introduction into the data mesh concept in general. So as you already mentioned, a lot of the things that we are trying to advocate here are more mindset changes, are like changes that happen more on the organizational side. And that's also one of the things that I want to talk about in a bit. But at first, the question is, of course, always, what can I do to support this from a technology perspective, from an infrastructure perspective? And that's exactly what I would like to talk about now, to give you the infrastructure perspective of things, of what were the biggest changes that we did on our side to help the company evolve towards a data mesh model and to help the company to grow stronger and to be supported by the infrastructure that is usually leading the charge in such kind of efforts. So the first thing that I want to say is just a quick recap of where we were actually coming from. Just a short reminder, we were in this position where the infrastructure team was always the bottleneck. We were in this position where like everybody had to go through the infrastructure team to solve their problems, but much rather we want to go to the perspective where we want to become the self-service data infrastructure platform, where it's unnecessary to always funnel all your requests through the central infrastructure team, but much rather a set of toolings are offered that are easily usable by the users. At the same time, we wanted to get away from this data monolith, which was our central data lake, towards these interoperable services that have these domain-specific data products that are then having and creating the possibility to build up on top of each other. Of course, all of this is a journey, and the journey starts somewhere. I introduced to you already the starting point where we were originally coming from, but the interesting thing is, of course, that even in this position, we already had a lot of things that were pointing us into a right direction. For instance, we already had a central data lake storage with thousands of data sets and petabytes of data. Of course, this is nothing that you just throw away from one day to another. We already had a global governance layer that was managing things like data access, that was managing things like automated metadata collection about what I already mentioned earlier, inventories about the data that you actually store, as well as usage analytics to provide people the information about who is actually accessing which kind of data sets. But this was where we started evolving our data platform, our data landscape. And that's where we started adding new, let's say, technology incentives for teams all over the company to start pushing for a more decentralized setup. The first thing that we added was a process that we call Bring Your Own Bucket, which basically allowed people to share data that they store by themselves. One thing that you need to know, Zalando has a setup on AWS where we are using many, many different AWS accounts. So it can be that almost every department, sometimes even every team, has their own AWS account where they are running their own infrastructure, but where potentially they are also storing their own data already as part of their processes that they already have. And what we were putting in is a very simple mechanism to share this data with the central platform. And that meant to not only have the physical sharing with the central accounts that the data sharing was funneled through, but at the same time also making this interoperable with the technical systems that were already in place so that they can also be used on top of these decentralized storage locations. The second part that I want to mention is to really simplify the data processing. And again, we had a head start here because we were coming from the central processing platform, which already gave the processing capabilities to users all over the company without taking the central responsibility for what they are actually doing with these processing capabilities. So as I mentioned, we had like a centrally provided Presto, which was just a multi-tenant system where anybody in the company could potentially run their SQL queries on top of not only the central data that we were storing, but also these distributed Bring Your Own Bucket locations. As I already mentioned, we had the Spark processing platform where there is one central team that was providing infrastructure to the rest of the company. There are like very easy templates of like how to request and create your own Spark cluster without needing to have the deep knowledge of actually running and maintaining it by yourself. We were coming from the background where a lot of teams were reinventing the wheel every day. And like even a lot of data scientists, they came into Zalando, they started to work on new and interesting machine learning problem. But the first thing that they had to do was spending 90% of their work to set up some infrastructure. And this was exactly the part where centralization of the infrastructure made a lot of sense, where now we are actually having a team with 3 to 5 engineers who are maintaining Spark clusters for more than 100 teams at Zalando. Lastly, we wanted to simplify data sharing beyond just cloud object storage. So we want to also use the part that we already had and extend it by additional technologies that were used by multiple different teams. This included like connecting some RDS instances where people were storing data in their own databases. This were included connecting some Redshift instances that teams were running to support their particular analytical use cases. And this is exactly the direction that we are going as well, that we are creating the base layer for central governance while we are expanding on the technology side to allow more and more teams to leverage the capabilities that are provided in a central way here. And this is exactly where I just want to point out once more that a lot of this is not about technology. A lot of this is really about how you set up your company-wide processes and how you create the incentives for the different teams to actually start going deeper into this direction. That's exactly where I want to also move over a little bit more to the organizational perspective of things, exactly because of what I just mentioned. The interesting thing that we learned was that decentralized ownership does not imply decentralized infrastructure. As I just mentioned, we are now having a setup where we have truly decentral storage, that the teams are responsible for their own data sets and they are maintaining them by themselves. Yet still we are in a position where we have central infrastructure that is centrally maintained, where you have expert teams who are providing infrastructure for the rest of the company. At the same time, we are now moving much more towards decentralized ownership. The moment teams started giving access to data sets that they store by themselves in their own local environments, we immediately saw a rise of responsibility that these teams were taking towards the data that they are storing and that they are providing. It was much easier to directly figure out who were the teams who were providing these data sets and to have a contact point that you could reach out to in case of any quality issues or in case of feature requests to further enhance your data product. At the same time, there was this decentral ownership. Again, we still had central governance. We still have the processes which are necessary to keep control about, like, for instance, who is getting access to what kind of data. And it's important to also federate these kind of processes in terms of who has to be involved into, let's say, granting access. But at the same time, it's important to provide central tooling to make these processes work. Because after all, interoperability is created through convenient solutions of a self-service platform. So just looking back once more at what I mentioned at the beginning, what were some of the biggest pain points that we were having? Datasets provided through pipelines of central data infrastructure teams always had this issue that there was this lack of ownership and there was this lack of quality. And the first thing that we did to move away from that part was to make conscious decisions about what data to actually store. We were coming from this background where all the data that was flowing through the company-wide event bus was default archived. And in theory, everybody could then get access to this data and to actually make use of it for analytical use cases. But a lot of these data sets were never meant to be used for analytical use cases. And that's why it was really important to also allow the producers the option to actively say that certain data sets should not be made available for analytics. Once use cases rose that were creating the need to provide certain data sets, much rather we were putting together the consumers that actually wanted to have access to this data and at the same time have them talk to the producers that were the ones who were actually, well, having the ownership for this data. And then together define how a data product could look like that would fulfill the needs of the consumer. And this led to a very big behavioral change when it comes to providing data and to really treat data as a product and not just as the byproduct that it was when it was just default archived everything that was ever available throughout the company. The second big point was that it was really important from each perspective of the platform to care about the users. The first thing that we provided as central metrics was to classify the usage of the different data sets. There were 70% of the data that were never touched, that were just lying around and creating a liability in terms of, well, costing money, but also in terms of needing to take care when it came to things like compliance topics, GDPR, antitrust, all these kind of things, where if you have data that you store, you need to take care of the data as well. There were, of course, data sets that had moderate usage, for which it made a lot of sense to just keep them as they are, basically. But what we also discovered was there was like this very small subset of data sets that were highly valuable, where it was really obvious that a lot of users were using this and were using it for analytical use cases, for machine learning use cases, and were creating a lot of value by using these particular data sets. And that was creating great incentives for the producers of particularly these data sets to start working on these data sets and to start improving the quality. And it enabled the teams to dedicate resources to not only get a deeper understanding of the usage of these data sets, but to then also invest these resources into ensuring the quality and into enhancing the data products that were already available further and tailor them really to the needs of the users that were creating the most value out of it. I want to share with you just some numbers of to showcase what is the adoption of this platform and of these changes that I've just displayed to you, so that you get an understanding of what is the kind of scope that we are talking about. Just a little bit of context, like in Zalando, we are dealing with like around 200 teams that are working in tech. Out of these, already more than 40 teams are using this bring your own bucket approach when it comes to just providing and sharing some data that they store by themselves so that they can leverage all the essentially provided capabilities on the governance side, but also on the processing side and on generally sharing and access of the data. More than 100 teams are using the processing platform and are getting provided Spark resources that they are using for their processing of these of their capabilities. And most impressively, we already have the first curated data teams which are building data products on top of other data products. So you can already see that the networking effect of providing data products that are interoperable, that can be combined and make further usage out of them, is already taking place here on our side. Most importantly, we got to the point where we actually had zero operational effort for the central team. Well, not exactly. It's a journey. As I already mentioned, we improved our situation a lot. We turned a lot of things much more into self-service pipelines, into self-service pieces of infrastructure, into self-service tooling, so that the central team is no longer the bottleneck that is just drowning in support requests all the time. But of course, there are still a bunch of things that we yet have to improve, that we are yet working on when it comes to actually moving more and further forward towards the target that we want to achieve with this data mesh idea that we are talking about here. As I mentioned, it's a journey, so I also don't want to leave out the forward-looking part. I want to let you know as well what are the things that we are currently working on. And this is something that I often like to call off-the-shelf data tooling, which basically has the purpose to provide teams with sometimes service pipelines, sometimes code snippets that just are like a Spark template on how to do a certain piece of processing of the data that you have. And just to give a couple of examples here, The first thing that we are working on is decentralized archiving, so that you can actually no longer provide central pipelines, but instead provide libraries that allow people to do and tailor the data archiving exactly to their needs. At the same time, we are offering decentralized GDPR deletion tooling. So when it comes to having deletion requests that have been brought in from the users of Zalando, that the teams that store the data decentrally get automatically supported with some nice tooling that solves the problem of GDPR data deletion out of the box. And lastly, and that's like the biggest part that I want to mention here, is template-driven data preparation, where we really want to get to the situation where you have something like a Spark template for certain types of processing, for certain types of aggregations, for certain types of, let's say, changing of formats of a data set, so that these teams can just very easy take some of these templates, tailor them to their needs, and speed up the productivity in starting to run these jobs in production. That's all that we had to share with you for today. And I was Max Schulze to talk to you today about the data mesh in practice. I was joined by Arif Vida, and we together want to thank you for your attendance.
Thank you very much, everyone.